There's about 56 different questions that we're trying to answer at our research farm, and then deliver that information to the farming community. We know improving the quality of the soil will help farmers build resiliency on their farm. When the weather is as erratic as it is, this is the only buffer that you have against that weather.
Hi, my name is James from Barn to Door. We help thousands of farmers across the country increase sales and save time online. Join me for today's session, 2021 Trends Every Farmer Needs to Know, where we're going to cover the tips and tactics that your farm can employ to build a thriving business online.
So I'm Deb, I'm the session host here, and we are lucky enough to have Dennis Hancock here from the USDA Forage Research Center. He's going to go ahead and talk to us a little bit. So I'll let him go ahead and share his screen and take it over. Thanks so much, Dennis.
Thank you. Appreciate the invitation to be able to be here with you all today, albeit virtually. I think we're all getting used to doing some of these Zoom sessions and with all their quirks and challenges. But I do appreciate the invitation. This is one of the first chances I've had to speak to the grazing community in the Wisconsin area, the upper Midwest, and really wanted to take a moment here to introduce myself a little bit, to give you a little bit of background on myself and how I have a passion for dairies, and in particular, looking at some of the grazing aspects of that. That's my disciplinary focus, my training here, and I won't go into all those details, but the last part of that, the PhD that I received, actually I was trained by a Kiwi, a New Zealander who was at the University of Kentucky, and that imparted in me a love for grazing and for forage management in general. The past 13 years, I've prior to coming in January of last year, to the Dairy Forage Research Center, I was a forage extension specialist at the University of Georgia, looking at all aspects of forage agronomy across the state. And I really have a passion for forage, cows, environment, and the farm family. So I had an opportunity to work a lot with many of the farm families in the Southeast, and and in particular, a lot of the grazing dairies. When I first came to Georgia, there was a growing interest in pasture-based dairying. And at that time, there were only a handful of dairy producers. One that's got his back to us here is Al and Desiree Weiner. Their farm in South Georgia was one of the leaders in that early days of grazing in the Southeast. And we held a number of field days, and the expansion of the dairy industry is pretty interesting there in response to that. In the Southeast, there in Georgia in particular, they had the luxury of center pivot irrigation, and that really was the key to the operation. But the other aspect of this, and I thought while I was on this picture, I would share the misting system that you can see here. This is a July photo of, you can see some cows there that have already gotten their fill for the moment, or laying down. If they were heat stressed, they wouldn't be laying down like that. You can tell that they have been able to cool down a little bit under that misting system. And in the summertime, even if you didn't have fences on the farm, they would stay right where that fence, that pivot is, because of the misting system that's on it. Just to give you a sense of what that looks like, this is how those style farms would be set up with rotational grazing, usually with 1 to 2, in this case 3 different irrigation pivots to be able to provide irrigation for those farms. We were really able to expand some of the pasture-based dairies there in Georgia, and I certainly am not going to take full credit for that. We had the opportunity because of the conditions, and we saw a substantial amount of expansion. While the remainder of the state, if you look at the all cow numbers, was on the decline, we actually saw a pretty significant expansion of pasture-based dairy cows when I came from about 2006, when I came on up to when I left in 2019. We had seen quite the expansion. Again, I'm not taking credit for that. I did my part to assist in that, but really it was a team effort, and there were many different folks involved at the state and state level, as well as in local regions. There were councils that were actively recruiting folks to come and join the location there. We also did quite a bit of research on those farms. We didn't have the capacity to do that at any of the research stations, but we were able to do some of that work on farm. Basically, it's a quick synopsis of what we found from a green footprint standpoint, is that the nitrate leaching was substantially less on the pasture-based dairies compared to the confinement dairies. Nitrous oxide emissions were similar. Ammonia volatilization loss and phosphorus runoff were greater for the conventional dairy, but the methane emissions tend to be higher in the pasture-based dairy. Now down there, you're dealing with C4 grasses, warm season grasses, lower digestibility, and we'll talk more about fiber digestibility in a moment, but that was one of the major challenges. The carbon footprint actually ended up being approximately the same per unit of milk produced, which was an interesting concept. And I think as time goes along and some of the advances of the carbon sequestration in the soil, that really is a major offset to a lot of those methane emissions. The dairies that we compared actually were 2 dairies as a case study. And I think there was some artifacts of that I think actually, I think a pasture-based dairy there, if we were to rerun that analysis, actually would come out a little bit ahead in that particular region. And the reason being is the carbon sequestration potential in those soils. This is a monitoring of some of the carbon levels in those soils in the time since conversion. And after an initial lag phase here, we entered into an exponential growth phase. And actually it was growing at a rate that's such as adding 0.3 of a percentage point per year added to the soil organic matter level. So within 3 years, that had increased a full percentage point. At the time, I really didn't believe that that was possible until we saw this data to confirm it. It was an amazing turnaround and really led me onto a path of understanding a little bit better how pasture-based dairies really have a great opportunity for carbon sequestration, and maybe the complete life cycle analyses haven't really fully incorporated some of that information about soil organic matter. And I think we may be in an opportunity at the Dairy Forage Research Center in the future to be able to assist with some of those life cycle analyses. Now that tells you a little bit about my history and my emphasis and passion for pasture-based dairying as well as all dairying. As a response to that, folks at the Dairy Forage Research Center saw me as kind of a leader in the Southeast and invited me to participate in the stakeholder committee. The U.S. Dairy Forage Research Center has a stakeholder committee of about 30 individuals who provide advice and guidance to the research programs of the center. And so about 3 years prior to joining as the center director, I had been serving as a stakeholder on the committee for the previous 3 years. And when the job opportunity came open, I recognized the unique nature of the Dairy Forage Research Center. In fact, our vision statement kind of says it all, which is we want to lead the world in integrated dairy forage systems research. And if you're familiar with our research center and some of the impacts that we've made over the years, and by the way, if you aren't, there is a good YouTube video that kind of summarizes our 40-year history. I was able to present this at the World Dairy Forage Expo back last October virtually, and it was recorded. It's archived on their YouTube page. And basically it lays out some of the historical impacts that our research has had on the dairy forage industry. So I encourage you to check that out. There's some really great information there, and some of the untold story, the unsung heroes, maybe even of some of the advances that we've made in the dairy industry from some of the scientists who have been at the center in our 40-year history. So now as we start in year 41 with the new center director, we retain that focus though on integrated dairy forage systems. And I want to give you just a real brief overview of our center to share with you how our center is set up, and so that you understand kind of the makeup of what we do. And I want to emphasize that we do have this integrated approach. It's really necessary that we have that integrated approach of looking everything from the soil and the forage, the agronomics, the animal nutrition, the environmental aspect of this. They're all working together in a multidisciplinary team, but we are divided into 3 research units. Let me break down these 3 different research units for you. The cell wall biology and utilization research unit is more of a basic science group. Our goal is to better understand dairy animal and forage physiology, and to better understand how we might be able to extract more efficiency out of that type of system. And then the second unit is really more of the applied unit, and that's the Dairy Forage Research Unit. And most of the work that I'll be talking about today has been work done by scientists in the Dairy Forage Research Unit. Then we have the Environmentally Integrated Dairy Management Research Unit, which has more of an environmental focus to that, trying to reduce the environmental footprint of the U.S. dairy industry. Now we have 8 scientists in cell wall, 9 scientists in the Dairy Forage Research Unit, and 5 scientists in the Environmentally Integrated Dairy Management Research Unit at present. We're actually in the process of hiring a few folks too. I also want to have you keep in mind that within the ARS, within USDA ARS, we have multiple locations working on various aspects of the same effort. And so in addition to us at the Dairy Forage Research Center here in Madison, we also have our colleagues at the Plant Science Research Unit on kind of more of a basic scale, looking at plants and soils here at the Plant Science Research Unit in St. Paul. Then in Lexington, Kentucky, we have the Forage Animal Production Research Unit, where they really look at a lot of the fundamentals of the forage interaction with the animal, looking at the microbiome, looking at, in their case, a lot of work with Endophyte, tall fescue toxicosis. And then also we have in Pennsylvania, the Pasture Systems and Watershed Management Research Unit. And so there's a lot of work that goes on, and for us to be able to really do it justice, we need to recognize our partners at these other ARS locations, because a lot of what they are working on is instructive of what we do here in Wisconsin as well. I want to just briefly introduce you to a lot of the folks who are going to be behind some of the research that I'm going to share today. And much of this work actually is done by Dr. Jeff Brink, who recently retired about 18 months ago as a longtime research agronomist with us. Mike Kassler, who is a plant breeder, will feature him in a little bit as well, because his role has been very pivotal in bringing new products to the market for the dairy industry, particularly the pasture-based dairy industry. Heathcliff Ryday is a legume breeder, and his efforts have been very crucial too. And then Wayne Koblenz, who is in Marshfield at the Environmentally Integrated Dairy Management Research Unit there. Wayne's also been involved with several of the grazing trials, and in the future, we'll have a lot more grazing work at Marshfield under Wayne's guidance as research leader there. But we are in the midst of hiring a new position for grazing systems in particular at Marshfield. So their focus will be to do grazing-based research there in Marshfield. So really excited about that. I'm over the moon about our candidates that we have. We've got some really great candidates, and hopefully we'll be moving forward soon with bringing that person on board. So I really think that we're just beginning to scratch the surface of what we're going to be able to do there. So our work kind of runs the gambit, and I'm going to talk about a few of these kind of in general terms and then a few specific examples as well as we go through. So one of the primary things that we've been working on is improving cool season grass productivity and persistence for pastures, and not only for grasses, but also looking at legumes that we can increase their productivity and their persistence in grazing-based systems. We've also been evaluating and selecting improved grass varieties, and then conducting some work to try to compare the improvements of those grass varieties and whether or not how much improvement we get over existing grasses in a typical setup of a pasture-based dairy farm. Then more of a fundamental look at the impacts of some of that grazing on the quality characteristics and the physical characteristics that influence pasture intake. And that can be very, very crucial, not only to the diet that is being selected, but the varieties that we choose to ensure that the diet that those animals are taking is ensuring that every bite counts, right? That we're getting as much energy and nutrition into that animal as possible. Then some of the work that Jeff Brink has been working on, I'm going to really dive into in more depth there. The residue height and timing effects on pasture productivity, quality, and persistence. And I think this is one that will really be a great take-home message for producers who may be on the call today. There's a lot of great work that came out of this. This is a picture, by the way, of those plots. And you can see some of the small scale. And obviously, what we're trying to do is mimic in a microcosm what many of you are doing in the field on a daily basis. So it can be quite challenging to do that in a smaller scale. And then if I have time at the end, I'll share a little bit of the work that Jeff Brink and Wayne Koblenz have been working on, looking at fall planted oats to extend the grazing season in October and early November timeframe. So as we go along, I'm going to talk about some of these principles of pasture management and how that is informed by our work. But what I want to do is to take a time from time to time, like now, to stop and see if there are any questions before we move on, because I want to make sure that we get a chance to answer any questions. And I'll ask our host, Deb, if there have been any questions that have come in by the chat box yet.
Looks like we don't have any at this time.
None at this time. Well, if you do have questions as we go, feel free to drop a few items there in the chat box, and Deb will graciously read those for me so I can try to respond. Well, let's continue on. Let's talk about some of those pasture management principles. And I want to start with how do we improve pastures? How do we improve those varieties that are on offer to our grazing animals? And I think it's first important to look at the species that we have available to us. These are the core grass species, the cool season grasses that we are producing here in the upper Midwest. And this is a typical yield from plants that are kept in a more of a vegetative state and provided, in this case, 60 pounds of nitrogen annually. Okay, now that in this case it was done experimentally using commercial fertilizer, but an equivalent of that in terms of organic nitrogen may also result in very similar types of results here. But the point I'm really trying to make is the relative differences between these species. And you can see that orchard grass tends to be very productive in this system. The tall fescue, at least the improved tall fescue varieties, the ones that are non-toxic, that do not have the toxic endophyte in them. Meadow fescue. Meadow fescue is one that we'll spend quite a bit of time talking about here for several reasons, which will become obvious as we go along. And then reed canary grass. And you know, orchard grass and meadow fescue and to some degree reed canary grass are the common ones that I've seen so far in my limited ability to be able to get out on dairy farms in the upper Midwest. Thanks COVID. I'm really looking forward to this all being behind me so I actually can get my gumboots on and get out to the field again. But what we can see here is the advantage of orchard grass, things like meadow fescue and reed canary grass in this system. But it's not just the yield that we have to think about, it's what's inside of that, because these plants really should be thought of as collections of cells, plant cells. And to make this as simple as possible, and I like to think of this in terms of two basic components. First is the cell contents, and the cell contents are easily digestible. Even you and I could extract the cell contents out of these forages if we were to consume them. It's the fiber component, the cell wall, the NDF, the neutral detergent fiber. That fiber component is what you and I would have great difficulty trying to digest. And that's where ruminant animals, of course, have got a great advantage. So for grasses, it's roughly 50-50. About half of the cell contents, or about half of the total contents, are easily digested cell contents. About half is fiber. And of that fiber, forage grasses generally have high levels of fiber digestibility. That's what NDFD stands for, is neutral detergent fiber digestibility. So of the fiber that is in that grass, about 75% of that fiber is digestible. Why is that a good thing? Well, those fiber strands are simply chains of glucose and other types of sugars that are just glued together. So those are simply chains of basic sugars that are just put together and linked together. Now, I say simply, there's nothing about this that's simple, really. I mean, but in a distilled version, that's basically what we're talking about. In grasses, for reasons we'll get into in just a moment, generally speaking, though, that fiber is a little bit more digestible than, say, the fiber that we get from legumes. Because in legumes, yes, we actually have more cell content, so overall the digestibility is higher, but of the fiber that is there, that fiber is less digestible. So the neutral detergent fiber there, neutral detergent fiber digestibility there is significantly lower. So if we were to put numbers to this, we can easily see that grass and legume fiber is substantially different. So if we look at grasses, about 50% of it's going to be fiber, and in legumes, about 35% is going to be fiber. For the fiber that's in grasses, about 75% of that is going to be digestible, whereas in legumes, it might only be about 40%. So the portion of the total diet that is digestible fiber in the form of grasses is going to be nearly 38% typically. And for grasses, it's going to be much lower, about 14%. And the reason being is how those different species are actually structured internally. Without really going into a lot of depth on this, I want to just give a basic way of thinking about this. This is the way I think of it. It's grass cells. If you look at the internal cell contents, those chloroplasts and everything, all those little organelles that are inside of the grass cell, those are easily digested just like they are in legumes. But in the legume cell, we have these, the cellulose and hemicellulose and the lignin. There's a lot more cross linkage there. There's a lot more connection. And even though some of that fiber is digested, there's still quite a bit that will remain as a result. And maybe you've seen this. Maybe you've noticed this in, you can see this actually in the feces of the animals sometimes, because grasses, animals that are on grass-heavy diets, that material tends to remain pretty stringy by comparison to that is in legumes. So those legume fibers generally will break into chunks, whereas the grass fibers tend to remain rather stringy as it passes through the system. And they have different passage rates as a fact too. So what we're seeing here in the case of the legumes is that they pass out of the rumen much more quickly than do the grasses. So they spend much more time, the grasses spend much more time in the rumen. They're more subjected to the bacteria that are breaking that down. And here's a scanning electron microscope of some of the images that the Dairy Forage Research Center has created over the years. And this look at some fiber that's being digested by some microbes that are working to help us out here. And that's really the livestock that is at work under a microscope. So if we take a look at a cross section of a grass leaf here, all of these cells in the middle here, those are mesosphil cells that are really easily digested by comparison. And all those chloroplasts that you see in orange here, those chloroplasts are where a lot of the starch and the sugar contents are going to be located. And so once that has been digested, this is what it looks like after 48 hours in rumen fluid, incubating in that rumen fluid. So what you're left with is all this vascular tissue, these bundles of vascular cells are what is remaining after digestion. Those are highly lignified and much more fibrous. And so generally speaking, those aren't nearly as digestible as some of these cells that are internal to that leaf. Okay, so let me pause again for questions that might have come up during that process before we talk a little bit about species differences and how that affects fiber digestibility. Any questions?
Still not seeing any. It looks like you're doing a great job.
All right, clear as mud, I guess. So,
Yep.
but what we'll try to do is, if questions do come along, feel free to write them in, and we'll try to address them as we get a moment. So let's talk a little bit about these species differences. And this is where we are going to really start diving into some data, because this is kind of very instructive to understand how to select a really good species for your pastures so that you're getting as much into those animals with every bite as possible. So I mentioned earlier about the yields of these different grass species, but let's look now at the digestibility, the fiber components, and then also the digestibility of these different grasses. Now, early on, you saw the mention of tall fescue, and our improved tall fescues can actually have pretty decent fiber digestibility. But notice that orchard grass tends to have slightly lower NDF and slightly higher NDFD, that's digestibility of that fiber. And meadow fescue is kind of, at the top end of this spectrum, has low fiber levels and really high digestibility of that fiber. And so that's really why, typically speaking, with most of our pasture-based dairies in the upper Midwest, we're typically going to be thinking about orchard grass, meadow fescue, and maybe some of these improved tall fescues as being real good choices there. So earlier I was talking about yield for the whole season, but really what we need to be thinking about is how does that line up with our calving season and our production season for these cows. And so if we look at the seasonal distribution of this yield under grazing, we can see that meadow fescue and orchard grass tend to be a little bit better there in the spring Then we have orchard grass and tall fescue being a little bit stronger in the summer, and then orchard grass tending to be a little bit stronger in the fall of the year. If we take that fiber digestibility number and we start diving into what do those look like in terms of fiber digestibility, well, it depends a little bit on the variety, but certainly the species are going to be different. So here's an example of an orchard grass. Now, it may not necessarily be the best orchard grass on the market, okay, just full disclosure there. But generally speaking, this is how these are going to rank out. And what you can see here is that the meadow fescue tended to be just, maybe 5 or 10 percentage points greater in digestibility of that fiber throughout the season. So a significant advantage there. And when we plug that into estimates of what the milk production would be off of that, what we can see is that meadow fescue would tend to lead in milk production per cow per day in the spring, would even retain that during the summer. And then for the fall of the year is going to be quite high too. Of course, that's production per cow. What does it look like if we look at milk production per acre? If we combine the yield and the quality together, what we see here again in the spring, there's advantages here for meadow fescue and orchard grass over tall fescue, but then orchard grass and our meadow fescue tend to be really strong here in the summer and then in the fall. So generally speaking, we kind of focus here more on meadow fescue and orchard grass as a result of this. Those tend to be our preferred species, and if you look at how animals graze, generally speaking, they like that meadow fescue and they really like orchard grass as well. So species differences affect fiber digestibility, but I want to make a point of saying that varieties can matter too. And this is where our team really starts to make a major push, because there have been many efforts on our part, particularly Dr. Mike Kassler, who is a plant breeder for us, in variety selection and breeding varieties that have higher digestibility. So for example, here is, this is some data, and that's a busy slide, so bear with me as we walk through it. But this is some data that just came out from Cornell. Okay, so this is not our data, this is coming from Cornell. Debbie Cherney over there at Cornell has put this out, and this is looking at meadow fescue varieties. And this is just a case in point, but this is NDFD, so this is the fiber digestibility of these different varieties. Now notice that there is one berry and tall fescue is a softer leaf tall fescue, and so there's kind of a standard for it. But if you look at Hidden Valley and Driftless, these are meadow fescue varieties that are really off the charts high. And that Hidden Valley was kind of the first release out of some breeding efforts. And really, that was one that was found by a producer where Dr. Kassler was out visiting with this producer on the farm. So let me dive in a little bit and talk about meadow fescue, because I think our scientist, in particular Mike Kassler, and his relationship with meadow fescue has really helped bring that particular variety to the forefront. And I think it's worth highlighting as the role that we sometimes play, many times kind of behind the scenes, that you may not even know this sort of thing is going on, but it really does play a role in shaping the industry. So meadow fescue, and older literature would call this Festuca pratensis, but the newer literature actually has this as the genus. So meadow fescue is a species that's been around the U.S. for quite a long time. But one day, Dr. Mike Kassler, who, as I mentioned, is a plant breeder at our Dairy Forage Research Center, was out visiting with Charles Opitz on Hidden Valley Farms. And what they were noticing, and Charles really wanted to have Dr. Kassler to go over to this little remnant oak savanna where his cows were hanging out, and they really absolutely would just graze this one particular area pretty extensively. And Dr. Kassler took some samples back from that, And it was kind of an unknown grass at that time. It wasn't really clear what it was. This was back in 1990 now, so this has been several years ago. And what they found was that it had the stem and leaf morphology of ryegrass, okay? Perennial ryegrass is one of which is just an outstanding grass for pasture, but unfortunately it's challenged in our environment to be able to keep it going. But it had the panicle morphology of meadow fescue. And so they identified it out. They ran DNA on it, and I'll talk a little bit more about the history in a moment of where they tracked it from and the origins of it. But I want to give you just a real brief history on meadow fescue, because meadow fescue in the U.S. and throughout the North American continent actually has been pretty extensively distributed. And for many years, it was one of the more popular pasture grasses that was brought over from Europe. Now, admittedly, in many of these locations, in many of these states, it's basically just going to be found in some, some out of the way places, kind of in the edges of a field, under shade or something like that, maybe a ditch bank. So there are going to be many areas where this is not extensively grown, but particularly here in the upper Midwest is really where it finds its happy home. Now, if we go back in time, we go back into the early 1920s, 1930s or so, meadow fescue was a fairly commonly sold fescue species, but it really wasn't a major player, and it really got supplanted by tall fescue, particularly when Kentucky 31 tall fescue was released as a formal release in 1943. That's when tall fescue really took off, and it became the most prominent cool season perennial grass across the continental U.S. Now, I would point out that some of the spikes that you see here in the ramp up of seed production actually are owing to some government programs and to try to stymie some of the soil erosion aspects and trying to convert many of these tilled areas over to pasture. But nonetheless, tall fescue really became much more dominant, and meadow fescue, which always had some seed production problems, especially out in Oregon, it doesn't produce nearly the seed that tall fescue does in terms of yield. And so it quickly supplanted, and tall fescue tended to dominate. But meadow fescue is one in which really has got a great history. It was brought over by European immigrants in a variety of different ways in which it came in, and I don't have the time to go into today, but Dr. Kastler was actually able to track that so he could understand a little bit better of where it came in from, and even back into Europe, where many of the varieties that we have, where they came from. But it only was able to survive because it kind of hung out in some of these intermittent oak savannas, just like they're at Charles Opit's farm in Hidden Valley. It was able to kind of hang out under those trees and survive that way. And only when we really started looking at it as a potential resource and bringing it out did we understand that it really had some great value and much higher digestibility and great yields to be able to sustain great milk production. Now, if you know about the fescue story in general, and in particular tall fescue, you know that some of these plants have endophytes that grow in them. Now, meadow fescue has an endophyte in it. It has an endophyte that lives within the stems, the leaf sheath, and the seeds. It actually grows in between the cells, and it is present. It's a mutualistic relationship between the host plant, which provides water, nutrients, and structure, and the fungus that actually provides some measure of anti-herbivory against insects and even some diseases, as well as drought tolerance, heat tolerance, and some other environmental tolerances. So it's a really crucial, mutually beneficial, mutualistic responsibility or a relationship between these two. Now, this particular endophyte in meadow fescue is benign to livestock. There are no problems. It does not produce the ergot alkaloids. Okay, unlike tall fescue that has the toxic endophyte in it, it does not produce those same alkaloids. So It's safe to be feeding to livestock. There's no drain on livestock performance because of that endophyte being there. Mike Kassler actually in his lab sampled over 800 plants, and 100 of those were from Charles Opit's farm and another 700 from 7 other farms in the region. And they found that all of those tested positive for endophyte infection using the ELISA test, which is just a standard test that is a protein reactive test to be able to determine if it's there or not. And certainly there is a fitness advantage to the fescue endophyte there in meadow fescue. The question is, what level of fitness is that giving to the plant? What kind of advantages is it giving to the plant? And it's still relatively unclear. So let me just take a moment there again to pause to see if there are any questions before we go on. Deb, is anything else coming too?
So there's been one comment question in here and take us off the path a little bit. It says the main grazing research questions seem to be about productivity, as if we're not producing enough milk at present when in fact we have a milk glut. Why are we not directing more research towards soil health, water quality, and biodiversity?
Great questions, and that's really the direction I'm going. And toward the end, I'm going to circle back to that to share a little bit about some of the work that's going to be in the future, and the new hire that we're making. That new person really is going to be focused on that. That new hire is going to be in our environmentally integrated dairy management research unit, and that will be the primary focus for that individual going forward. And I'll talk a little bit more about that in just a moment. Any other quick questions, Deb?
It looks like all we have.
Okay, so let's talk a little bit about getting started here, and how do we look at our pastures? Should we be renovating these? Should we be improving these? And certainly, you know, at a certain level, we do have to maintain a competitive level of productivity. And one of those ways of doing that is to improve our pastures, to make sure that we're providing good nutrition for our animals and you know, being very efficient with our overall scheme. So this is a study that Jeff Brink was involved with. I think there were several UW folks involved in this project as well. And what they did was they looked at 5 different farms, kind of in a north-south transect here through Wisconsin. And essentially what they did is they took a paddock here and they divided it kind of randomly for existing management. They basically just left it as it was, and then they chose a certain area that would be renovated and improved with the new pasture varieties. So improved varieties, improved species selection, getting really the targeted species that we're shooting for here. So here's the renovation timeline. In this case, it was done in September of 05 and then sown in 06. And the principal focus here was with orchard grass and meadow fescue, and there were some legumes that were added a little bit later, I believe. All these treatments were grazed simultaneously whenever the producer decided. So it was the producer's management year from July 2006 on to 2009 when they terminated the study. So here's the difference that was made here. So we have the light green is the existing yields, and the darker green are the renovated fields or renovated areas. So you can see the yield advantage. Now, the existing pasture, because it was already existing and didn't have that first year of trying to get up to speed, it led the yield by about 14%. But then in the future years, you can see that there was a significant advantage for more yield from the renovated pastures. So 23%, 21%, 12%. If we look at the pasture composition that was present here, and this is the location in Iowa County, 38% meadow fescue, 17% orchard grass, 21% bluegrass, tall fescue, quackgrass, a little bit of clover or no clover there to begin with, and a few weeds. And what you can see here is after the renovation, you can see more of the dominance of the meadow fescue and the orchard grass in the sward. Now you can already see though that some of this orchard grass is starting to slide backwards a little bit, and part of this has to do with you know, the environment and trying to make sure that you're matching your pasture species with the environment that you're planting into. But notice what happened here. We basically saw a reversion back to the same percentages. Now, there may be improved varieties that were used here, but you're seeing a reversion back to those original conditions. Similarly, in Taylor County, we see more of an advantage for orchard grass, but by the time the 2009 came along, the grazing conditions and the environmental conditions of that location shifted away from that. And the challenge here is because of a variety of conditions of that particular location, whether it be the soils, the environment of those years. But the things that are under our control, of course, are grazing too often, grazing too short, grazing at the wrong time. And this is where we run into less production and less persistence. And regardless of your situation as a grazer, whether you are an intense high input type of grazing operation or a lower input grazing operation, the next few bits of what I'm going to share with you are really, really crucial to understanding how we better manage our pastures to not just be productive, but to make sure we're not having a negative environmental impact on our surroundings as a result of that. So let's talk a little bit about it. If we are allowing adequate residual, grazing residual here, and if we're only grazing down to say about 4 inches in the case of orchard grass here, and we're allowing adequate residual, when that plant begins to grow again, most of that regrowth is going to be fueled by photosynthesis, not actually reserves. Whereas if we don't leave very much residue, most of that is being reactivated carbon from the storage organs here at the base of the plant. And that's what's fueling that regrowth. It's basically tapping into the savings account every time to regrow. So a good simple study to try to illustrate this was done in the greenhouse, and they would come in every so often and at different time intervals, and they would clip this plant, these different plants, either to 2 inches or to 4 inches. Now, here is meadow fescue and its response to being clipped periodically at 2 inches or 4 inches. And here is orchard grass's response to that. Now, you can quickly see some real challenges that are coming. We've talked a lot about yield and productivity, okay? You can definitely see some yield differences here. But I also want to point out differences here in the soil. Notice the difference in the root mass between this level of residual grazing height. So that grazing residual is at 2 inches. We have much lower root mass in both of these. We also have much lower tiller numbers. Okay, so if we look at that data in more detail here, and this is a range of regrowth, amounts of regrowth and cutting intervals, basically what this is saying is that under that 2-inch grazing, or simulated grazing in this case, we're really drastically reducing our yields, usually by 25 to 50% or more. But we're also reducing the roots that plant is producing. Now think about this in terms of some of those environmental concerns that we were talking about earlier and resiliency of the farm. If we are in the middle of a drought, which one of these pastures are going to be the most resilient to that drought system? And of course, those that have less root are going to be much less resilient. Secondly, think about the canopy that is there. And with the lower tiller numbers, you're going to have more access to the soil and therefore many more opportunities for soil erosion, or even things like greater runoff of nutrients from those pastures. as well as increased weed pressure. So you may end up having some challenges in that regard as well. So there's a couple different strategies that one can have here. One is to, from a grazing perspective, one can look at trying to keep the plant vegetative, or going with a longer rest and allowing for more mature forage to be consumed. And there's a variety of different discussions about that, about different grazing systems, which I won't get into here. But let's talk about this in this particular trial where they looked at both kind of scenarios. They had one scenario where they were trying to keep it in that vegetative growth, and they would start at about 12 inches of pasture mass before they went out, and they would either graze that down to 6 inches of residue, 3 inches of residue, or really tightly graze it down to 1 inch of residue. By comparison, they also had a scenario where they allowed that plant to be much more mature. They would allow it to accumulate 20 inches of material. Then they would defoliate it, graze it down to 10 inches or 5 inches or 2 inches. Okay, so we have vegetative and mature, two different kinds of experiments here going on at the same time. And the previous slide actually shows the setup there. This is when everything was kind of uniform toward the end of the grazing season, and you can kind of see how that was actually set up. So let's start with the vegetative one. Here is the results if we graze down to a 1, 3, or 6 inch residue. And this is the grass that was grazed, the mass that was grazed through the season. So with a 6 inch residue, they were able to get in 7 different grazing events. And if we look at the yields there by comparison with the 3 inch residue, they only got 6 grazing events. With the 1 inch residue, they were only able to get 4 grazing events during that season. All right. Now look at the round, the speed at which we can rotate here. With a 6 inch residue, because we never grazed it down, or in their case, they didn't never graze it down too tight, and it was still in a linear phase of growth. It was very much in that that linear phase of the regrowth cycle. If you've ever read grass productivity, you're familiar with the grass curve, the S-shaped grass curve that is talked about there. In this case, what we're able to do is to come back and graze every 20 days versus every 25 days versus every 30 days for that 1 inch residue, 40 days. It was taking 40 days for it to recover back to that targeted grazing mass of 12 inches for the vegetative orchard grass. Now let's look at for mature orchard grass. If we grazed mature orchard grass, we allowed that to accumulate to 20 inches and then go down to 10 inches of residue, or 5 inches of residue. In this case, both had 3 grazing events. But notice here the difference here in the time lag. With the 10 inch residue and the 5 inch residue, they were getting about 55 to 60 days. With the 2 inch residue, that extended it out to 80 days. So if we look at the total productivity, all right, so for the vegetative orchard grass, the total productivity tended to be the greatest here for kind of a middle level of residue. But here's the key consideration. This is not a 1 year in a vacuum. You have to be thinking about what's happening down the road. And in this case, looking at what happens next spring. How long does it take for that to accumulate to 12 inches next spring so we can start that grazing season all over again? And in the case of the 6 inch residue, they were able to start on April 28th. For the 3 inch, it was about a week later. And for that material that was grazed down to 1 inch, it set it back enough that it was roughly 2 weeks later than the 6 inch residue before it accumulated to that 12 inch high. Okay, so that does make a difference. It also makes a difference when we're dealing with mature orchard grass. Now, there wasn't quite as much of a difference here, basically a week between the 10 inch residue and the 5 inch residue. But notice here for the 2 inch, then we're looking at, again, about a 2-week delay overall in what would happen later on the following spring. Okay. And again, one of the big things that would happen in these cases would be the reduction of the tillers. The impact on tillers, you have about 25% fewer tillers when we're grazing it really tightly. And this was with meadow fescue. The response to orchard grass would be even worse. If we go back to this, this is a good image that compares the two. Orchard grass, in this case, up at the top, meadow fescue and orchard grass. The orchard grass is going to be much more sensitive to that, and this is the result that you would see in the tiller count. So you can see the tiller count is much, much lower in orchard grass, and for meadow fescue, this is the average of 2 and 4 inch cuttings. Meadow fescue is much more prolific at producing tillers. Here's an image of that, kind of looking down on the canopy of the pasture. This is a 6-inch residue that was left behind. If I can find my cursor again, where did it go? There we go. There's the 6-inch residue here on the left, 3-inch residue in the middle. And, you know, once we get down to the 1-inch residue, you're seeing much fewer tillers. And if we get a major rain event here, we're going to see a lot more you know, brown colored water that's going to be running off of these pastures and contributing to our challenges with, you know, water quality issues. I also want to bring to bear when this overgrazing occurs, or when this rapid grazing occurs, really has an influence on the overall scheme of things too. So what Dr. Brink and his colleagues did was they tried to think about a scenario of when, if you're going to have to come back to a pasture real quickly, where it doesn't, you're not allowing it really to accumulate back up to the target grazing height. If you're going to run into those scenarios, what's the long-term impact of that? Obviously, you've got that short-term reduction in yield and productivity of those pastures. But then maybe you're also going to have some longer term impact from that. And so what they did was they set up a scenario where they would purposefully come back and graze a couple times at 6 inches of starting grazing residual height down to 3 or 4 inches, versus allowing it to get up to about 12 to 14 inches before they would start grazing. So they would do that either in early spring, midsummer, or in late fall. And so this is the way it was set up. So they had a control down here where it was continuously, well, not continuously grazed, but they were rotating the cows through there. They were grazing at only once it got up to 12 to 14 inches. And then they had a scenario where they would graze it twice in May at 6 inches. So just a really fast round. An early round, as some of my Kiwi colleagues would say, an early round. And then in July, it would be that same fast structure. So it's kind of simulating what would happen if we got into a dry spell in July. If we grazed it twice at 6 inches in July, what would happen? And then if we grazed it twice in October. And I just want to take a moment here for you to think about, okay, what do you think is going to happen? So what do you think is going to happen when we overgraze it in May? Not overgraze it necessarily, but graze it quickly and have a very short recovery there in May versus July versus October. Well, this is what the data shows as a response. So if we overgraze or graze twice at 6 inches here in May, the yield loss for that month was about 400 pounds of dry matter. Okay. If that was occurring in July, you got 200 pounds less yield during that month, but you also set it back such for the remainder of the season, you lost about 600 pounds per acre for a total loss of about 800 pounds. Now, overgrazing it or grazing it twice in quick succession in October, it did not seem to reduce the total yield that much. Okay, it's already starting to go dormant. What this tells me, and I think this is something that's a real take home for most of our grazers, is they really need to have an emergency forage option in July. Really need to be thinking about some level of a contingency plan for your forage plan in July. And a good contingency plan would be to consider the use of warm season annuals. And there's some great work that we have got on looking at BMR sorghum Sudan grasses, BMR Sudan grasses, and BMR pearl millet. Unfortunately, I'm getting really tight on time, and I want to cover one more subject, but there's some really good information about this. Actually, it just came out this year, the kind of the last of Dr. Brink's research was just published earlier this year. And basically, the long and the short of it is that any of these three will work quite well. If you're going to take, say, a baleage cutting off of this, the Sudan grass or the sorghum Sudan grass is probably going to be a better choice for you. Plant it, relatively early in the summer, and that first 45 days or so after planting is when it's going to be most productive. So your first flush of growth, you might want to store that off as baleage because that is one that will be difficult to graze. It will get ahead of you pretty quickly. Pearl millet, if your soils are capable of producing it, pearl millet actually tends to have a little bit higher dry matter digestibility, fiber digestibility. It tillers out. You can kind of see it's a little bit more spread out. It tends to tiller out at the base, and it kind of throws out elbows and takes up space a little bit more than the one or two stalks that would come off of sorghum or sorghum Sudan grass. So what you can see here is differences in growth pattern, but in terms of grazing, I can tell you from experience with cattle grazing pearl millet, it's a little easier to keep up with it. In the early part of the summer, the sorghum Sudan grass and the Sudan grass is going to be much more productive, but through the rest of this summer, the pearl millet is going to hang tough and really be more forgiving under that. All of these will work. It just depends on your goals. Okay, so what your goals might be. And in most cases, all of these will work. There are certain environments where you might want to choose one over the other. So consult your local agronomist for an extension agent for more advice on that. This last little section I'd like to get through before we hit questions, and maybe we can hit all those questions at once. This is some work that was, again, relatively recent. Looking at fall planted oats for extending the grazing season, and I wanted to share this material. This is a fact sheet that is published on UW's Wisconsin Team Forage webpage, and it lays out the details of this, and including the results. Fall-grown oats are really the best choice for a cool season annual grass to plant after one of these summer annuals, for example. Because it's not all that reliant on day length or vernalization, so it can be planted in early August and stockpiled as long as practical. You can use it to extend your grazing season pretty significantly, but if you're doing this with heifers, one of the key things to do would be to train them to an electric fence before turning them out there. Just make sure they're aware of what that fence is there for. Time grazing is generally going to be your best bet there to try to stretch that resource as possible. Allocating about 20 pounds of dry matter per heifer per day to graze that out. And the strategy here would be to use frontal grazing. Frontal grazing is a variation on strip grazing, and many of you might be familiar with strip grazing or break grazing, as you might have heard it called. Basically, where you work through a progression, they graze this out, you move on to the next strip, and they graze that, etc., until at the end of it, you cycle back again. Well, with stockpiled forages, we would want to use a frontal graze because we're really not worried about regrowth. These fall planted oats are not going to regrow. They're not going to come back next spring. So we're going to go ahead and graze it all out. We're going to start on the end where the water trough is located, and then like a front moving across the field, we're going to just keep moving that front fence. Don't worry about a back fence until it's all utilized. So looking at the accumulation of those fall forages, so some years you're going to get a really good response to that. And you can see some really high tonnage here from the fall oats. But in some years, like the drought year of 2012, it can be pretty challenging to get much out of it. So just be aware that that risk exists. Some years are going to be good years, and other years are going to be a bit more challenging in that regard. And generally speaking, the utilization rates can be really high too. So you're getting a good use out of that forage. Plus, you're able to hold the soil and prevent some erosion and nutrient loss there too. So what's next? Where are we heading? Well, one of the major areas of development that we're looking for is really trying to get more of our heifers out on pasture, trying to improve the growth, the health, lactation, and the efficiency of those animals, but also looking at the impacts that has on the rumen microbe and the overall health of those animals. But a major focus of our research, or especially our pasture research going forward, is going to be looking at the contribution of those grazing animals on environmental factors. And that includes things like nitrogen in the urine and manure, and how that's impacting the productivity of that pasture, and then also looking down in that soil profile as to how that those nutrients are leaching through the soil profile. We also need to understand some of the pasture management effects on the quantity and quality of runoff from these pasture-based areas as well. So that's another key aspect of where we're going in the future. So just to kind of sum up here, but as we get close to the end of our time, I wanted to leave some time at the end for some questions. I just want to highlight some of the many areas that we do work in. This is a short list, if you will, of the different research endeavors that we have going on at the Dairy Forage Research Center. A lot of this is well beyond just looking at productivity. We're looking at things that impact emissions and methane emissions, carbon footprint, etc. And I was just reviewing an article yesterday over the weekend where we were looking at efficiency of the system per unit of milk produced, and really to be good stewards of our land base, we need to make sure that we are as efficient as possible, because that really actually a whole farm approach, a whole farm system of best management practices to try to mitigate the environmental impact of dairying really is the crucial answer to some of the challenges that we have as it relates to our carbon footprint and our environmental impact of the dairy system. So I encourage you to check out some of that information online. There's a lot more that I didn't get into because of time. Here's a link to our website. And also want to highlight some work that we have ongoing with cover crops. There's a lot of synergisms between cover crops and the use of those as alternative forages within the dairy industry, and we've been active and engaged in that part. You saw a little bit on the fall oats as a strategy for holding the soil and extracting some nitrate from the soil. So those webinars are free if you'd like to sign up for any of those dates. Several of our scientists will be engaged on the April 2nd session. So I really encourage you to check that out. And with that, I'm going to stop for questions. I hope I've left about 10 minutes or 10 or 15 minutes worth of time for questions. Any questions that you might have?
Yeah, so we did have one came in. It says, is your data about the orchard grass MF and TF from grazing pure stands, grazing mixed with alfalfa, or as hay?
So I think everything that I presented here today was for grazed systems. And we have some for both, but most of that is for grazed systems. The only exception to that was there was the one study from New York that I mentioned. That I believe was actually I don't actually know the parameters of that. I've showed that just to show the varietal differences there. But everything I've talked about today, I believe, has been from a grazing perspective.
Okay. Another question that came up, has there been any research on grazing warm season grasses?
So yeah, I kind of ran out of time on that. Let me see if I can, hold on just a second. I kind of ran out of time on talking about some of the grazing of summer annuals. There hasn't been as much of the grazing work for summer annuals as we have some of the original plot work. And that was toward the end of Jeff Brink's career. I mentioned that there was the last study that he had published was of some of that, looking at yields and fiber digestibility and those sorts of things of those. Actually, I did before I left Georgia. Now, obviously, it's a different scenario, different environment. Did some work with grazing of those summer annuals, and I'm happy to share my experiences with you. In fact, the varieties that we used are the same varieties that tended to rise to the top in Jeff Brink's work as well. So the varieties are the same, the principles are the same, the applications may be a little bit different. But generally, as I described, is what they found here as well, is that any of those summer annuals actually could work quite well. It's how you grazed it and how you fit it into your system. So if you're looking at solely grazing, my suggestion would be to go with pearl millet. If you're looking to try to bank a little bit of forage, my suggestion would be to look at either the BMR Sudan grass or the BMR sorghum Sudan grass. They're a little bit harder to stay on top of from a grazing standpoint. They can get away from you a lot quicker than pearl millet can, but they're not quite as overall productive either. So that's the challenge. Pearl millet, on the other hand, tends to have a little bit better dry matter digestibility, fiber digestibility. So that's your real advantage. I would say that either of those actually work well in mixtures. Part of the studies that I did when I was in Georgia was looking at mixtures and using things like, in our case, we were looking at forage soybeans, cowpeas. We were even using some crabgrass in there too. And all those tended to work pretty well, but the sorghum Sudan grass and the Sudan grass tend to allow a little bit more open underneath the canopy to allow some of those co-mixes, the mixes in that species mix to thrive as well.
Along those lines, what states would best grow BMR pearl millet, sorghum, and Sudan grass or Sudan grass? Would these grow in Minnesota, Iowa, South Dakota?
Well, I'm not familiar with those particular locations. I would suggest you'd really need to talk with someone, one of your local extension personnel, to really get some greater guidance on that. I can tell you from our research with Marshfield was one of the locations, so that's central Wisconsin. So that would be somewhat on par with the latitude, say, of St. Paul, Minneapolis, in Minnesota, and then certainly in Prairie du Sac and points further south. Pearl millet did fine in our data, in our trials. So I think there would be some challenges if you were to deal with some really wet soils or something like that. You may have some greater challenges there. Although Marshfield is extraordinarily wet, it did pretty well up there too. So I would have to beg out to say that in that case you would need to consult local experience there with your local extension service. But in general, it seemed to work fairly well. It's worth a shot, I would think.
Okay. A couple of things. Aren't summer annuals counter to soil health? And then what about summer perennial warm season grasses?
Yeah. So summer perennial warm season grasses, there's a whole lot I would love to talk about those because I have a lot of experience with warm season perennial grasses, particularly the natives. I think there's some real opportunities, particularly with big blue stem and Indian grass. Those are two that are extraordinarily productive. Some great research with that, by the way, even though it's a great distance from the upper Midwest, but a lot of that work has been done at University of Tennessee. They have a center for native grasslands there, and some really great work on establishment and how to integrate that into the system, and animal performance data. They're the only of a handful of folks I know of with any kind of animal performance data. Now, granted, it's not dairy, okay, but that is an area that I would like to see some more work done on. It's really challenging though to do that. It requires a lot of land to be able to do that, and that's one of the biggest challenges that we have is the cost and the expense of doing some of those larger scale feeding trials or grazing trials to be able to do that.
Okay, so I have a couple comments here. I'll go ahead and read off. It says, we grazers and organic farmers would like to see a lot more plant breeding and new varieties of grass, legume, and forb species. Grassworks, the organization, has helped get Hidden Valley Meadow Fescue to market because of the resources at UW. So grazing management is key.
Yeah. Yeah, the Hidden Valley there was a collaboration with UW and our center at Dairy Forage, and Mike Kastler was really the main one to get that out, and it was important for us to make sure that that variety was an open source variety too. It wasn't one that ended up getting protected by plant patents and that sort of thing. It was one in which it was important for it to be a public release. Honestly, it's one of those that I don't think would actually have made it from a marketing standpoint had it not been a public release, because of the tendency of the challenges of making it fit into a seed production model out in Oregon, and it just doesn't yield well seed-wise in Oregon. It has to be something more locally produced to make a go of it. So it's one of the things I'm really proud of our center's role in that, in partnership with UW, and Mike Kastler's legacy, I think, is tied up in that particular one. So to elaborate on that a little bit further, we have a grass breeder and a legume breeder. We fully anticipate continuing on with that. Those are crucial parts of our research endeavor at the Dairy Forage Research Center. And frankly, there's just not very many of those as public resources out there anymore. I mean, we're one of the few facilities and institutes that still maintains a public breeding program. There's very few universities that still have that. And there are a handful of us within ARS that have plant breeding programs still yet.
Great. Along that same lines, on what you're doing at the Dairy Forage Research Center, can we look forward to a dedicated grazing herd there at the new dairy?
Well, we will have a grazing effort at Marshfield for sure. The new research dairy in Prairie du Sac, the way it is set up, it's just not going to really fit the mold for what we need it to do. Believe me, I've tried to make it work. It just isn't going to work out the way that I would really like for it to do. Now, that doesn't mean that we won't be doing grazing work there. What that does mean is that we are going to have to continue some of the work that Jeff Brink has been doing, looking at pasture productivity and that sort of thing there. Now at Marshfield, we do have plans on doing some lactating cow research in the not too distant future as well. They have the land base to be able to do that, and the willingness, and the I mean, our partners there at UW are great, and they are very willing to integrate some pasture-based lactating cow work there. So yeah, it's not as simple as starting a grazing dairy, but we're going to have to chip away at it as best we can.
Great. And apologize, I'll back up just a little bit here. It says, we do have a comment that says comparison should always be on both a per unit product and per unit land basis. The former will always privilege the notion that we need to extract more. Quick comment.
Yep.
And then does the Dairy Forage Research Center have an extension function, and how what's the best way to browse and access the research studies and results from the Dairy Forage Research Center?
Yeah, so as Ag Research, the Ag Research Service, we do not have a extension function per se. We do have an outreach function, which differs in that we can come out to help troubleshoot on occasion, but it's really not, that's not really our role to be doing troubleshooting and that sort of thing. We can certainly come out to be speakers and to share our research, but there is a kind of a defined line between what is extension and what is ARS. That being said, though, we do have a presence on our website. We have a lot of information on our website. In fact, I'm going to be copying and pasting into the chat box here. Let's see if I can make this where everyone in attendance can read that. Hopefully you can see that. The first line there is our website. It's a mouthful, so I've pasted it there for you to visit. On that, you can get an archive of webinars and seminars. We do webinars now twice a month, the first Wednesday and the third Wednesday of every month at 3 p.m. And those are archived on our website. All of our publications, every publication that we've been on since 1995 is available on the website, or at least an abstract of it is available on the website. Any of our research publications that are published in peer-reviewed journal articles have to be available as open access as well. So there's a treasure trove of information in our publications archive, and I'm not sure that the average person really recognizes the resources that are there. There's also a list there. I think there are 38 books, something like that, 38 different textbooks and resources that are listed there that our scientists have either contributed as co-authors to it, or they were the author of it, the editor of the assemblage of all that information. So every major textbook in the industry of the dairy forage world has had somebody from the Dairy Forage Research Center, generally speaking, as an author or co-author in that material the last 40 years. So there's a pretty good amount of information on our website in that regard. I encourage you to check that out. If you're interested in our seminars and you'd like to get on our mailing list about that, there is a page there on our website where you can click on that to email our secretary to get on that list, and they can set you up to get those alerts.
Great. So it looks like we're right at 2 o'clock. And we did have one comment, not a question, but it's a really interesting presentation. So thank you,
Thank
from
you.
one of our participants.
Sounds good.
So I think that's everything. So thank you again, everybody, for joining us. We appreciate everybody coming on, and hope you're able to enjoy some of the other sessions. Thank you so much, Dennis, for coming on. A lot of information, and I'm sure there's quite a few of us that could sit here for another couple hours and dig more into this. So thank you so much for your help. And that's everything for this session.